Here's a simple question. If you had two cars, one for 20,000, one for 45,000, which would you buy? Obvious, the cheaper one. But what if that cheaper car only runs 5 hours a day? What about the other 19? This is exactly the problem we have in the energy debate. When someone says solar is cheaper than nuclear, they usually have one number in mind. That number is LCOE, levelized cost of electricity. LCOE is a real metric. It's not a wrong one, but it's not enough. And this episode is about that gap between not enough and wrong. LCOE means take a power plant, add up all its costs over its lifetime, divide by all the electricity it produces. How many dollars per megawatt hour? This number is genuinely useful. It tells you what it costs per unit of electricity to build this plant. According to the joint IEA and NEA report from 2020, for plants commissioned in 2025, the median LCOE for utility-scale solar is lower than the median for nuclear. That's real. I'm not disputing it. But that same report, the same IEA and NEA, says something else that fewer people pay attention to. It says LCOE is a useful tool, but as the share of variable sources like solar and wind grows, it needs to be complemented with another metric. That metric, system cost. Let me give you an example. Say you have a city. You decide to power it with solar panels. Noon. Great, sun's out, electricity flows. But 8 p.m., people are home from work, ACs are running, electric cars are charging, and the sun is set. Now what? The answer is the system needs something else. Storage, or backup generation, or transmission lines to wherever the sun is currently shining. All of that costs money, and none of it is in the solar plant's LCOE. That's system cost, what the grid has to pay to accommodate a variable technology. The OECD's Nuclear Energy Agency, the NEA, published a research report called The Costs of Decarbonisation. It modeled 8 different scenarios, from 0% variable renewable share to 75%, all aiming for the same target, cutting carbon emissions to 50 grams per kilowatt hour. What did it find? Number 1. At 10% variable renewable share, system cost is around $7 per megawatt hour of electricity those sources generate. Relatively small, manageable. Number 2. At 50% share, that number becomes $30. The system cost has gone up roughly 4-fold, while the share only went up 5-fold. This isn't linear, it's accelerating. Number 3. At 75%, system cost reaches $50. Now put these next to LCOE. If solar's LCOE is $40 and its added system cost in a 50% scenario is $30, what's the real cost per megawatt hour? That's the question LCOE alone doesn't answer. Let's pause for a second. I'm giving you these numbers, but I don't want the wrong conclusion drawn from them. System cost is real, but it's variable. It depends on how flexible the grid is, how much storage exists, how connected it is to neighboring systems. The same NEA report shows that in a 50% scenario, with a more flexible system, system cost ranges from $28 up to $48. That's a wide gap. And by the way, nuclear has system costs too. It needs strong grid connections, it needs a cooling water source, it has siting constraints. The difference is, according to this same report, those costs are roughly an order of magnitude lower than the system cost of variable renewables. An order of magnitude, meaning roughly 10 times lower. So the right question isn't, which technology is cheaper? It's, what mix of technologies delivers reliable, low-carbon electricity at the lowest total system cost? And that question is far more complicated. The same NEA report has a scenario called low VRE cost, assuming solar and wind costs drop sharply. In that scenario, what does the optimal system look like? 30 to 40% wind and solar, 40 to 60% dispatchable low-carbon sources, like nuclear or hydro. The rest, flexible resources. This isn't a defense of nuclear, and it isn't a rejection of renewables. It's the output of an optimization. Next time you see an energy comparison, ask one question. Is this number just the cost to build it, or does it include the cost to integrate it into the system? If the answer is just the build cost, know that you're seeing half the picture. This is Reactor Atlas, exploring nuclear energy through physics, not fear.